Lesson 2-5, Solving Systems of Inequalities. Before we get to the actual graphing parts, we want to go through a couple of vocabulary words that you may see in your problems. When they talk about feasible regions means the area of the graph on the graph where all the answers of the systems are graphed. So really it's the shaded parts that they all overlap. Now when they talk about bounded and unbounded, bounded means that it's completely surrounded. The shaded area is completely bounded around all four sides or all the sides. Unbounded means there's an opening on one side that continues to go on to infinity. So how are we going to do this? Step 1, graph each inequality by graphing the related equation and shading the correct region. Step 2, identify the feasible region that is shaded for all of the inequalities. This represents the solution set of the system. So our first example, solve the system of inequalities. For these, when we graph it, we're going to graph them like a linear line. So make sure they're in y equals mx plus b format. So the second one, if I divide by -2, I now have y, instead of greater than, it's less than because I'm dividing by a negative number, -1/2 x. Okay, so I'm going to use green for this first one. I'm going to graph this one, y equals 4x minus 3. So I put a point at -3 on the y-axis. Slope of 4, so go up 4, 1, 2, 3, 4 to the right one. Up 4, 1, 2, 3, 4 to the right one. Or I can go down 4, 1, 2, 3, 4 to the left one. Since this one does have an equal to sign, I'm going to use a solid line. The other one I'm going to use blue for. Here I'm going to do y equal, because graph 1/2 x. So the y-intercept's at 0, 0. 1/2, so it goes down 1 to the right 2. Down 1 to the right 2. This one does not have the equal to sign, so this one's going to be a dashed line. So just remember, solid line if it's less than or equal to or greater than or equal to. It's dashed line if it's just less than or greater than. Okay. Now the shading part, we will have to shade in here. And to shade here, just going to, you can pick a test point as long as one of the lines doesn't go through the origin, or you have to pick a point. For me, I would just do, it says here it's got to be less than the green line. So underneath the green line, that means here or here. And then it's got to be less than the blue line. So underneath the blue line, so here or here. The only part that has 2 yellow dots is this bottom part. So the solution would be here. Now I can pick a test point to see if that's true. If I pick the point 1, 1, which is right here, 1, -1. If I put a 1 in for x and a -1 in for y, I would have -1 is less than or equal to 4 minus 3, which is 1. -1 is less than or equal to 1, so I know that works. And if I did -2 times -1, it has to be greater than 1. So this is 2. 2 is greater than 1, so I know that this point is true. Next, graph this one. Here we have 3 of them here. So I'm going to first use red for this first one. So I'll put a point at 2. Use a slope of 1/3. So up 1 to the right 3. Down 1 to the left 3. Or I can keep going up 1 to the left 3 or to the right 3. Since it does have the equal to sign, I know it's going to be a solid line. I'll use green for this next one. Y is greater than x, so just think of y equals x. So that means 0, 0, 1, 1, 2, 2, 3, 3, and so forth. Since one does not have the equal to sign, this is dashed. And then we'll use blue for this last one, y equals 1. So it can equal 1. So I'm going to have a solid line going across at the y equals 1 mark. So it has to be below the blue. So I'm going to put a blue dot where it's below the blue in each of the sections. For red, it has to be underneath the red. So that covers here, that covers here, that covers here, and that covers here. And that also covers this piece right here. Then green, it has to be above the green. So above the green, that means here, 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 here. So which one has all three colors in it? The only part that has all three colors in it would be this piece right here. So it's underneath the red, underneath the blue, but above the green. Next, graph the solution system of inequalities here. So I'll do this one in black. So put a point at -1, up 1 over 1. Since this does not have the equal to sign, I know this is going to be dashed. I'll just make this a dashed line. So here's our dashed line. Next one I'll make green. Has to be greater than or equal, greater than -2x. So this one's at 0, 0. Up 2 to the left 1. Up 2 to the left 1. Or I can go down 2 to the right 1. This one's also dashed. Okay, so it has to be above the green. So above the green means here or here. And it has to be above the black, which is here or here. The only place I can see that there's two different colors is in this section here. So this would be our solution. Going on to our next example, example 2, it says bounded regions. So solve the system of inequalities. So we're going to do the same thing here. First one I'm going to do in green. Do this one here. So put a point at 5. -4/3. So down 4 to the right 3. Down 4 to the right 3. This one does not have the equal to sign, so this one's going to be dashed. Use blue for the middle one, so put a point at -2. Has a slope of 1. So dashed because it does not have the equal to sign on it. Actually, no, that one does have an equal to sign, so this is a solid line. Then we'll use red for the last one. X is greater than 1. Crosses the x-axis at 1. Doesn't have the equal to sign, so this is just dashed. Okay, so it has to be greater. Greater than means it goes to the right. So either here, here, or here. For the blue line, it has to be above the blue line. So here, here, here. And then for the green, it has to be below the green. So here, 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 or here. The only place that I see 3 colors So we've got to put the red in here, so that's to the right. So the only part that has all three colors is just this piece right here, this little triangle. This is bounded because it's covered on all three sides of the triangle. Next, graph the solution of the system of inequalities here. So I'll use green for this first one. 4/5 x minus 3, so put a point at -3. 4/5 goes up 4, 1, 2, 3, 4, to the right 5, 1, 2, 3, 4, 5. We're down 4, 1, 2, 3, 4, to the left 5, 1, 2, 3, 4, 5. Has the solid line so it can equal it. We'll use blue for the next one, +2, down 2, to the right 3, down 2, to the right 3, where I can go up 2 to the left 3. This one does not equal. This is dashed. Then we'll use this purple color for 0. So it crosses the x-axis at 0. It's a solid line. So it's greater than, so it's to the right of the purple. The blue one is underneath the blue. And the green one is above the green. The only place that has all three, again, is this middle triangle. So that would be our solution. Next, graph the solution of the system of inequalities here. So the bounded region, again, so let's do, I'm going to make this 1.5 is 3 halves. That'll make that easier to when you're graphing it. So we'll use blue for this first one. So point at -2. And then we have up 3 to the right 2. Or down 3 to the left 2. It has the equal to sign, so I know it's a solid line. Use red for the next one. It's got to be greater than or equal to -3x, so that's 0, 0. Up 3, 1, 2, 3 to the left 1. Up 3, 1, 2, 3 to the left 1. Or I go down 3, 1, 2, 3 to the right 1. This one has the solid line because it can equal it. Use green for the next one, x equaling 2. Dashed line because it cannot equal 2. And then we'll use black for the last one. It has to cross the y-axis at 4. The solid line because I can equal that. So it has to be less than the black. The blue one, it has to be above the blue. For the red one, it has to be above the red. And the green, it has to be less than the green, so underneath to the left of green. The only one that has all 4 colors would be this section here. Going on to our next one, it says Niagara Falls boat tour company charges $19.50 for adult tickets and $11 for children's tickets. Each boat has a capacity of 600 passengers, including 8 crew members. Suppose the company's operating costs for one boat tour is $2,750. Write and graph a system of inequalities to represent the situation so the company will make a profit on each tour. Then identify some viable solutions. So part A, we need to write the system of inequalities. Part B, we're going to graph the system of inequalities. Part C, we're going to identify some viable solutions. So part A, we need to write the system of equations. So it says a company charges $9.50 for adult tickets, $11 for children's tickets. Each boat has a capacity of 600 passengers, including 8 crew members. Suppose the company's operating cost for one boat tour is $3,750. So that means we have $19.50. We're going to use adults as your X and children as your Y. So we have $19.50 X plus 11Y has to equal a total of, that's company operating cost for one of the boat tours is $2,750. So you can't go more than $2,750. So we're going to do, this one has to be, it's going to be more than that. So at least $2,750. So that would be greater than or equal to $2,750. The next part, we know we have X adults plus Y children plus 8 crew members. This has to be less than or equal to 600 because there can only be a capacity of 600 passengers. And another one for adult tickets, we could just only have children tickets in here. So this would be greater than or equal to 0. Can't have negative there. And then Y would also have to be greater than or equal to 0 if we were only using adults. So those are our inequalities that we want to use or to graph on our coordinate plane. Part B, we're going to graph that system of inequalities. So for here, we're going to count by 50s on our X's and Y's. So this would be 50, and then this is 100, 150, 200, 250, 300, 350, 400, 450, 500. I might have to count by 100, so let's count by 100. So 1, 2, 3, 4, 5, 600. And the other one will count by 100s as well. This would be 100, 200, 300, 400, 500, and 600. Let's graph the first one. We can do the So let's write down our inequalities again here. I'm going to use X and Y. So I have X plus Y plus 8 is less than or equal to 600, which this can be written as X plus Y is less than or equal to 592. And the other one would be 19.5x plus 11y is greater than 2750. So the bare minimum is 22,750. So it's going to be more than that. Then we have the other ones are x is greater than or equal to 0 and y is greater than or equal to 0, which just means it has to be in quadrant 1. So to graph these, we're going to graph the intercepts because that will make that easier. So for this one right here, the intercepts would be when x is 0, y is going to be 592. And when y is 0, x is going to be 592. So I'm going to have a point roughly here and a point roughly here. Since it can equal that, we're going to have a solid line. And then for the green one, we'll use this one. So we're going to do the intercepts for this one when x is 0 and then when y is 0. When x is 0, 2750 divided by 11 gives us 250. So on the y-axis, we have 250. So that would be roughly here. And then when y is 0, 2750 divided by 19.5 gives us about 141. And 141 would be roughly here. Since this one does not have the equal to, this one's a dashed line. And it's got to be below the blue, but above the green. So below the blue and above the green would be this part right here. So now we just need to choose some viable solutions here. So now, if we chose 60 adults and 100 children, if I go and plot that 60 adults, 100 children, so adults would be your x, and children is your y. So if I did, let's do red, so if I did 60 and 100, 60 and 100 would be roughly here, or like there. So viable, so that's not viable. So this would be non-viable. Next, 210 and 350, 210, 350, 210, 350 would be roughly in here. That would be viable. 415 and 200, 415, 200 would not. Next, 390 and 240, 390 and 240, that would not be viable. The last one, 550 adults and 0 children. 550 adults, 550 adults, that would be viable. So any answers inside the shaded yellow spot would be a viable solution. Moving on to our next example, the International Club raised $1,200 to buy livestock for a community in a different part of the world. The club can buy an alpaca for $160 and a sheep for $120. If the club wants to donate at least 8 animals, determine the system of inequalities to represent the situation. So our two inequalities, the first one, 160x, I'm going to use x for alpacas. I'm going to use y for the sheep. So $160 for each alpaca plus 120 per sheep has to be less than or equal to 1,200 because they only have $1,200 to spend. Next one would be alpacas plus sheep have to be at least 8 animals. They want to donate at least 8. So at least means 8 or more. So these are our systems. Now, if I were to do the intercepts, for the first one, if x is 0, y would be 10. And if y is 0, x would be 7.5. And then here we would have 0 and 8, and 8 and 0. So let's come to our equation, or our coordinate plane, and we can graph those. So let's put those order pairs again. So we got 0 and 10, and we have 7.5 and 0. The other one would be 0, 8. And we have 8, 0. We'll count these by ones. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10. This would be 1, 3, 4, 5, 6, 7, 8, 9, 10. So let's plot these. So we got 0, 10. And we have 7.5 and 0. And since these can equal it, we're going to have a solid line. So this one's a solid line. And then the other one, let's do black here. So we got 0, 8. And we have 8, 0. This one would cross like this. Now it's got to be below the red, but above the black. So that means the shaded part would be right here. Now we can answer the questions. So select all the viable solutions given the constraints of the club's funds. So if we have 0 alpacas, can you buy 10 sheep? You can do 10 because that's one of our intercepts. If you did 1 alpaca and 8 sheep, let's go back to that 1 alpaca. So 1 and then 8 sheep. So 1, 8 would be right here. So that would work. 3 alpacas, 6 sheep. So 3, 6. 3, 6 would be 1, 2, 3, 4, 5, 6. 3, 6. That would also work. And then 6, 3. 6, 3 would be 6, 1, 2, 3. 6, 3 would also 6, 3. Let me go back to that. So 6 and then 3. Since I have a little bow, this one would not, because technically this line goes down like here. So no, 6, 3 would not be in there. If you're unsure whether it would work or not, you could put a 6 here and a 3 here. 160 times 6 plus 120 times 3 would give us 1,320, which is more than 1,200. So that one will not work. 8 and 0. 8 and 0. So 8 and 0. So 8 and 0. This would not be it because the other one crosses over here before that. So 8 and 0 would not work. So our only viable solutions are A, B, and C. D and E do not. Moving to our last question. Noelle plays electric bass in her school's jazz band and contrabass in a community orchestra. She needs to practice her electric bass for at least 6 hours per week and her contrabass for at least 8 hours per week. But she cannot spend more than 20 hours each week practicing. Part A, write a system of inequalities that represents the situation. Let X represent the amount of time spent practicing electric bass, and Y represents the amount of time spent practicing contrabass. So we have X plus Y. Together, they can't be more than 20. So this has to be less than or equal to 20. And the other one says you have to practice at least 6 hours per week for her electric bass and 8 for her contrabass. So other ones we would have, since X is the amount of times with the electric bass, we would have X has to be at least 6 hours, so greater than or equal to 6. And then Y has to be at least 8 hours, so greater than or equal to 8. This one I'm just going to subtract X on both sides so I can graph it. This would be Y is less than or equal to a negative X plus 20. and x is greater than or equal to 6, and y is greater than or equal to 8. So let's put that down. So y is less than or equal to negative x plus 20. Y is greater than or equal to 8, and x is greater than or equal to 6. So if we were to graph these, let's count by twos. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20 there. So let's do the first one, put a point at 20 on the y-axis. I can go down 20 to the right 20, so that's a slope of 1. So I can equal that, so that's a solid line. The other one has to be greater than or equal to 8, so across the y-axis at 8. And then the other one crosses the x-axis at 6. So it has to be underneath the purple. So that's here, 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 and here. It has to be above the green. So here, here, here. And then it has to be to the right of the red. Here, 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 or here. The only one that has all three is this piece right here. So that would be our solution to that part. Now the question, there's actually no other question that we would have for that because part B was just to graph it. So anything that lands in the yellow would be a solution to this system of inequalities. That is our lesson on solving systems of inequalities.